Hello everyone, welcome back. Today I want to talk about a bigger topic in C#, but I will try to make it short and still easy to understand. So we want to talk now about data types. Data types in C# are a very important topic. If you create a variable, the last time we stored data in it, whatever kind of data it is it a text, is it a number? We didn't really care, we just pushed it in and we used dynamic. Maybe you remember that. If you don't, go back to the last video, check it out, watch it, and then you can come back and you will know. So dynamic is not always a good option. Why is it? Dynamic accepts every type and only validates during the runtime. But the compiler, while compiling your program, will never know what is actually happening. Dynamic is good if you have a type that's not known during compile time and only known during runtime. Let's say you have a Python program that you want to control. Then you can use dynamic because Python is a dynamic language, so you don't always know the type. Another thing would be if you have like a kind of C class that's maybe unknown and you want to use it, or you want to pass an JSON file if you don't know what it is, not that important now. Then you can also use dynamic, which is still not always the perfect solution, but there are many reasons why dynamic could be good. I showed you that to make it easier to understand for the first, but now I want to dive a bit deeper with you. And I want to talk about data types. Let's go to the next slide to just show you the first example, because I think that makes it easier to explain it to you. So whole numbers in C# are a thing. So we have whole numbers, we have decimal numbers, many different kind of types. I will not show you every type that exists in C#. I will only show you the most important ones that you need even for starting. And here you have a big list. So what you can see is already a minimum value, a maximum value, the size, and the type. What exactly does this mean? Maybe you heard of bytes. Bytes are bits, 8 bits. You have 8 bits in 1 byte. So in a programming language, you don't really talk to bits. You can work with bits, but that's a more advanced topic. For now, you just need to know you don't really talk to bits like the 0 and 1s everyone is talking about. You have 8 of these 0 and 1s, so these bits, and they combined are a byte. This byte is so 8-bit, and it starts from 0 to 255. But you can also say like, hey, I want a byte that is a minus number, a negative number. Then you have S-byte, for example. S-byte starts at minus 128. Why does it not start at minus 255 and goes to 255 like byte does? The difference is that S-byte is still a byte. It contains 8 bits. And these 8 bits need to get to the same number. So they have a limited size. Like at some point, if you have 8 bits, there is a maximum reached, and this is 255. More than this is not possible. So if you want to have negative numbers as well, you need to calculate it down. So you move it back, so it doesn't start at 0 anymore. Here it starts at minus 128. So that means the maximum number goes down as well. And then we have a short. Here we have 16 bits. That means they are 2 bytes. And because we have 2 bytes, we get, of course, a higher number. This one. And then we have U short. Here is the same. So here we start at 0 and go to 65,535. Here's a little difference. Bytes, it's a kind of convention thing, starts at byte, and negative is S byte. But normally you can always remember if it starts with an U, it starts at 0. If it doesn't, it has a minus compatible number. Byte is a special case, so just remember that. And we can go up here to 64-bit, and here we have a much higher number, as you can see, so there's much more possible. The basic number that we normally need in the most cases is int. Int is short and means integer. Integer is 32 bits and offers the most used range. Sometimes you need a uint, but most of the time just an int. And there's not much to say. You can choose whatever you want. Like if you just use numbers 1 to 10, you know it always fits into byte. So why not just using byte? The good thing is you use byte, you use less memory on your computer, which can be much better than directly using an int, which uses more memory on your computer. But if you have a number like 300, then you will know this doesn't work anymore. You need to go higher. And then you could go with short, for example, or U short. And yeah, the most people just choose int, even if it is just a 10 or a 1. But be careful, just because a number can be 1, maybe it can also be 500. In this case, yes, 1 fits into byte, but 500 doesn't. So always choose wisely. Here on the right side, we have an example. This is how the integer would look as we did it before. Dynamic, the old dynamic age, and it is 30. And the new typed age is with int. So instead of dynamic, we would use int. And then just the number as before. The difference is, here the compiler didn't really know what is the plan that we want to do. Here he knows. So if we start compiling and we added a decimal number maybe, then he knows, oh, something is wrong. Or at least he wants to warn us that something happened. Because it might be a problem if we pass a decimal number to an integer. As you can guess, a decimal number contains a comma, and then after the comma some other numbers. And if we have an integer, it will just cut off at the comma. So at 2,5, we only get the 2, and the comma 5 gets lost. And that's not good. And here the compiler directly knows what is the plan, what do we want to do. And if I go to the next page, here it is completely the same. We start at 32 bits, and this is a float. Float is less used. I don't know if I ever used it, but yeah, I did, but normally I go with double. Double is, I think, the most go-to way in C# that you use. It is 64 bits, and here on the right side we have an example again. Here it knows, oh, we work with double, so decimal numbers are accepted. Here a special case if you directly want to say, hey, I'm not using a float, I'm not using decimal, I'm using double. Then you can just add a D after the 5. You can basically just remove the D. The compiler will know what you want, but to make it more clear on the right side, you can just write a D. Decimal should be an M, and float should be an F, if I'm correct. So it's the same like integer basically, just now with a floating point number. Decimal is basically the same like double. You see it is much bigger, but decimal is a special case. If you have some calculations, it could be that double goes the wrong way. This is normal, but this is why we have decimal. Decimal is like if you make a selling system where you want to sell things with and you need to calculate your money, then this money must always be an exact number, an exact calculation. Double can run into problems with that after a while. So I would always go with decimal, because decimal is more exact there. But the normal way to go with is double, because for normal cases it's normally fine. But for these super exact cases, I would always go with decimal. And yeah, that's basically the difference. Then we have a Boolean. Boolean is like 0 and 1 basically. No, it is not a bit. Even if it sounds like that, it's still a byte, as you can see, because a Boolean is 8 bits. But it represents like a true and a false value. So you say like yes or no, or you say like I accept or I disagree. Boolean is like if you say like, hey, if this is activated, then do this. Otherwise, do something different. And you couldn't make this decisions or logic in C# if you couldn't say if it is true or false. And this is where this type comes in. You can basically say, do I agree this privacy policy? Then the user can click on accept or not accept. And if he accepts, you can put on button press the value true into bool, and then you can later check this Boolean value. Bool means Boolean, and you can check this Boolean value if it is true or false, if you accept it or not. And this is Boolean. And if we go to the next page, here we have some more special cases. Here we have a char. A char is 16-bit. It's not just 8-bit, it is 16-bit, even so if we have just a smaller number. This is the case because we have UTF-16, or I saw UTF-8. I think it was UTF-16, I'm not really sure right now. Anyway, this one just stores one single character. That means if you have like an A, if you have a B, if you have a C, you don't directly need to use a whole text variable like string, where we come to in a bit. You can just do it in char. There are a lot of advantages of using char instead of string in this case, but we will get to this in a completely different video far in the future, because it's not something that I would teach in beginner. So if we look at text now, you can see the text looks the same like char, but look at this votes. They are double. We don't use this single ones anymore. Single ones always means char. So if you come from a JavaScript background, maybe, that doesn't really matter if you use double quotes or single ones. But here, it totally matters. You need to care about that, and A is always a char. If you write a B next to it, it will fail compiling. If you do this in dynamic, it will also fail because you use the single quotes, but dynamic is still the more unsafe version, so you should always work with a type system. Yeah. Here we have the string. String is basically a text, and it can contain a huge number, so I just left this away now. The minimum value is basically null, so nothing. If you make it nullable nowadays in C#, but that's a topic where we can go to another video because it's just for the beginning now, so you need to know string is like a text with many chars, so if you have many of them, you would just use the string, and then you write like hello world, and you use string here. Yeah, that's for the video today, and I hope you understood everything. Otherwise, feel free to leave a comment below and ask your questions. If I see there are questions that I cannot answer with just a comment, I will make another video. Otherwise, thank you for watching, and the next video will come already soon.